All right, we're live. Hello. Got 3.6, 3.7 implicit differentiation in the chain rule in store for tonight. Let's set up the iPad while we're waiting for people to join. Set up the iPad. We got a viewer. Hey, viewer. Okay. We have got iPad. Let's put it on the screen. All right. Pull the chat back up. Hey, chat. Got 3 people in the chat. How's it going, chat? Having a nice night. 8:30 p.m. on a Monday night. Nice Monday night. Nice quiz on Wednesday. Got our live review popping off here. I've got the review guide pulled up. Got the new iPad. Very nice. Very exciting to have the new iPad. And we've got 3 people in the chat. Wondering how everyone's doing. Just got some nice problems. Getting ready to solve these problems. We're going to let people get in for a minute. But we're ready to go. We're ready to solve these nice problems. Chain rule and implicit. This is the review guide right here I pulled up. Do whatever problems you guys want, but I think these are good. Second derivative, unsimplified form, because it's nasty. You don't want to have to simplify that. Some more implicit, number 8. We did a problem real similar like number 9. 10's a great table problem. Tangent, got a bonus challengey type question. Cool. So we got 6 people in the chat. I did promise that we would do problem number 2, and that's kind of where I'd like to start today, because problem number 2 can be pretty challenging. Whoops, copy, and we will add a page for problem number 2. It's not even the calculus that's hard with problem number 2. It's really paste. There we go. It's really the algebra that's hard with problem number 2. So if you're just joining us, we are going to start with problem number 2 in the review guide, which is finding the derivative of this quotient right here, which I'll use the quotient rule. You can swing the radical up to the top and call it -1/2 power and just use the product rule if you wanted to. I tend to avoid negative exponents as much as I possibly can because they are not fun. So let's see if we can find the derivative of this thing right here. So the derivative f prime of x is equal to the bottom function, which we'll just call x to the 9th plus 9 to the 1/2, okay, times the derivative of the top, which is 2x, minus the top function times the derivative of the bottom. So if this right here is x to the 9th plus 9 to the 1/2, its derivative, the 1/2 would have to come down. 1/2 would have to come down. X to the 9th plus 9 to the -1/2 power times by the derivative of the inside. The derivative of the inside is 9x to the 8th power. And that is everything. All divided by the bottom squared. And the bottom is a radical, so if you square a radical, the radical just goes away. So this is just equal to x to the 9th plus 9. The chat's quiet tonight. We had Janice say a message and then retract a message. So hello Janice, how are you? This is the beginning of problem number 2. So now I just need to simplify it. That's all the calculus involved. Simplifying it. The only thing I'm worried about here, we got negative exponent I'm worried about. We got like terms here that I'm worried about that we should probably combine. So let's see what we can do. Let's see then. I'll just kind of bring the 2x in front, and then this is x to the 9th plus 9 to the 1/2 power minus, and then I'll multiply the 9x to the 8th and the x to the 2nd, giving me 9. And I'll also multiply the 1/2 actually. So 9 times, I'll highlight 9 times 1/2 is 9/2. And then it's x to the 10th times x to the 9th plus 9 to the -1/2 power, all divided by x to the 9th plus 9. And this is my derivative. I just need to make sure. Hi, Jackson. How are you? Need to make sure I get all these like terms simplified in this negative exponent away. So I think I was actually working this out in class today with Sarah, and we found the best way to do this is to just multiply by x to the 9th plus 9 to the, what was it? Was it the 1/2 power? I think that'll do it. If we multiply, I'm going to get rid of my equal sign for a second. If we multiply everything by x to the 9th plus 9 to the 1/2 power over x to the 9th plus 9 to the 1/2 power. I think it's going to clean up pretty nicely for us. Wouldn't even be mad if you stopped review to watch the Bruins game, one of the best games yet. I'll catch the Bees game later. No worries, Alexis. So if we distribute this x to the 9th plus 9 to the 1/2 power, this right here, the 1/2 power and the 1/2 power, the rule is to add exponents. That's just to the first power. So this would be 2x times x to the 9th plus 9, now raised to the first power, minus 9/2 x to the 10th. And then if I do a negative 1/2 power times the 1/2 power, that actually makes the 0 power, which becomes 1, which makes the term entirely useless. It could just be like a times 1 right there. But you have to do the same to the denominator, and the denominator is just x to the 9th plus 9 to the 3/2 power, because I have the first power times the 1/2 power is 3/2 power. And then I think I'm chilling. I just need to multiply out the numerator. So it's 2x to the 10th plus 9 times 2 is 18x minus 9/2 x to the 10th. Got to remind, just checking it real quick. Won't let me on the review. Says it's restricted, coming from Emma Scheibel. I don't know if anyone has a way to get the review from not being restricted that I could message Emma back. Definitely let her know. Emma Scheibel's having some trouble connecting. I also didn't send a remind out about this one. I said I was going to. Oops, my bad. And then we're just going to jump back into this problem. We're going to divide by x to the 9th plus 9 to the 3/2. Okay, and then I probably can just combine these terms here. 2x to the 10th minus 9/2 x to the 10th. If I just erase this 2 and I call it 4/2, I could subtract and get negative 5/2 x to the 10th plus 18x over x to the 9th plus 9 to the 3/2. And I'd say the only other thing to do is get rid of fractions within fractions. Let's multiply the numerator and the denominator by 2, and I'll be done. So that'll be negative 5x to the 10th plus 36x over 2x to the 9th plus 9 to the 3/2. And now I've successfully fulfilled all Shack simplification rules. Check in the chat. Best to just turn off restricted mode. Could be her Wi-Fi from James. Okay. Let's message Emma telling her to turn off restricted mode. Okay, I have to log in to remind. This is neat. Okay, sign in with Google. Or I tried that, and you asked me to log in. Good times. All right. We are going to message Emma back. Chat says turn off restricted mode. See if that works. Okay. Hopefully that'll work for Emma. It stinks if you're trying to get in, you can't get in. That's no fun. All right, so this is problem number 2 completed, and we've got the rest of the review packet available. Let me know if you have any problems you'd like to call out in particular. There's a lot of good problems. Number 4 is a really good chain rule problem because this particular function has 3 layers, and that's pretty abnormal, seeing 3 layers in there. I believe we did number 5 in class today in 2 out of 3 of my classes. One of the periods we did a separate problem, but number 5 using Leibniz notation. We just did that. Slope of the tangent of the ellipse at the point square root 2 comma negative root 2 over 2. So that one's nice. It's not asking you to build a tangent or a normal. You just have to take the derivative. That's a good one. We did number 7 out in one of my classes. It proved to be just a very long algebraic process, but it's not too bad because you didn't have to simplify the second derivative. Let me know if I pass one you'd like me to do. This review session is completely for you. Number 8, the 2 sine x cosine y equals to 1, finding the equation of the derivative. That's not bad. Number 9 is very similar to the classwork problem we did. Number 10 is always a good problem, just finding the derivative at 1 of h of f of g of x over f of x, always nice. Equation of the tangents, x squared plus y squared is 25 when the slope is 3/4. And then the bonus, which was the two circles of radius 4, the tangent of y squared equals 4x. At the point 1, 2, find the equations of the circle. So that's just kind of like an epic challenge problem. We could certainly do that if you'd like. Look into the chat for suggestions. I'd be happy to do everything, but I want to know what you guys feel like you need help in. So we'll just kind of wait till someone calls out a problem. Meanwhile, we'll check their mind. Can you do 11 and the bonus? I can absolutely do that, Jackson. We're going to check in with the Remind crew, see how everyone's doing. Okay, nothing back. So I'm hoping that Emma got in. If Emma did not get in, I hope we can get her in eventually, or she can just watch it afterwards, I suppose. But we're going to go to 11 for Jackson. We're going to go to 11. Okay, here's 11. Oh, no, that's 10. Here's 11. Okay, find the equation of all tangents to the circle x squared plus y squared is equal to 25, where the slope is 3/4. All right, in order to solve this problem, the first thing you have to do is find the derivative using implicit differentiation. So let's go ahead and start that first. So the derivative, which I'll notate with derivative because there's no way to write like f prime x or anything, is equal to 2x plus 2y dy dx is equal to 0. This is the derivative of the function. I could divide through by 2, giving me x plus y dy dx is equal to 0. Okay, and the next thing I need to do is isolate my dy dx. So I'm going to subtract x and divide by y, giving me an answer of negative x over y as my derivative. Now, I actually told you what I wanted the slope to be. I wanted the slope to be 3/4. So what I'm going to do in this problem is set my derivative equal to positive 3/4. And really what I need to do is create some kind of an expression for x and y using this. So I'm going to cross multiply here, and we're going to call this negative 4x is equal to 3y. And if I solve, I suppose it doesn't matter too much which variable I decide to solve for, because I have the equation of both variables up top. X squared plus y squared is 25. So I think I'll just divide by a negative 4 and call this negative 3/4y is equal to x. And then what I think I'll do is I'll take this and I'll plug it back into the original formula for x, and we shall solve. So let's go ahead and go to a new actually, I'll go to a new page in a minute. I'll just see if I can get one line written down. We'll do it over here off to the side. So this is negative 3/4 y squared plus y squared is equal to 25. I got on another computer. Awesome. Emma Scheibel's with us. Yes. I'm glad it worked out. We were trying to troubleshoot for you. And that's as far as we got, is turning restricted mode off. So I don't know if that helped, but we're doing problem number 11 right now in the review packet. So we got this squared plus y squared is equal to 25. And I think all I have to do now is just solve this thing and see if we can figure out what the values would be. So if I solve this, I would get, let's see, if I square the negative 3/4, I would get positive 9/16 y squared plus y squared is equal to 25. And so this is, I don't know. I guess I could just combine the like terms, I suppose. I could add 1 and 9/16. So that would be what? That'd be 26, so it would be 25/16 y squared equals to 25. I could then, I could divide both sides by 25. 1/16 y squared is equal to 1. If I divide both sides by 25, and now I can multiply by 16. So y squared is equal to 16. So I get that y is equal to plus minus 4. So I get y is equal to plus minus 4. And then I can just use my x formula here, negative 3/4 y. Sorry, I was going to move to a different page. It's a little messy as a result. I'll try to clean it up. But this is what we've got. Oop, I lost that part of the equal sign. So I got this. So let's go to a different color here. Let's suppose that y is equal to positive 4 and y is equal to negative 4. Let's make a little chart here. So negative 3/4 times positive 4, negative 3/4 times negative 4. So this one's going to work out to negative 3, and this one's going to work out to positive 3, giving me the coordinate points negative 3 comma positive 4 and positive 3 comma negative 4. And these are the these are the coordinates of the tangents. And so I need to find the equation of all tangents where the slope is 3/4. So I suppose I just need to do y minus y1 equals mx minus x1. And I know the slope of both of them is 3/4. So I'm practically done. I'm just going to scooch my green work up for a bit and see if, oh, okay, see if I can, oh, all right. Yeah, no, we got it. Just got to do it quick. Look at, oh, almost had it. Oh, no. There we go. We got it up there. All right. And I'll just squeeze them down there in the bottom here. So it's y minus 4 equals m x plus 3, and y minus 4 equals m x minus 3. Just make sure I got my signs right. Negative x, positive y, and then negative y, positive x. That looks good. So here are my equations of all my tangents, where the slope is equal to 3/4. And they're tangent to the x squared plus y squared equals 25 comic. So problem done. All set. Check it in. Chat is quiet tonight, but we are happy to be here. We got 13 viewers, which is great. I know I was not sure if I was going to be here entirely, but we did it. I got another request for the bonus, so I'd like to do the bonus, which is just like a kind of a harder, tougher question than normal. And it says 2 circles of radius 4 are tangent to the graph y squared equals 4x at the point 1, 2. Find the equations of the 2 circles. Well, the curve kind of looks like this. Y squared equals 4x as a sideways parabola looks something like this. And so what's happening here is that I've got my coordinate point 1, 2, and it looks, 1, 2 is like somewhere over here. And so what's happening, if I draw my tangent to the curve right here, I'm essentially trying to build these circles. I'm essentially trying to build these circles. So they'd look a little bit like this and this. They'd kind of be like right here. And so what we can assume, oh, I cannot draw that. That's not going to go well for me. I'll try to scooch it over here. There we go. That'd be a little bit better. What we can assume is that, oh, I tried. All right, we'll just scooch the other one over. There we go. Interestingly enough, the center of the circle will lie on the normal of the curves, because the normal, which is this like line right here, is actually perpendicular to the tangent, right? It's perpendicular to the tangent. So that's actually where the normals are going to lie. And so I think we can probably jump into the problem. We know the radius is 4. And so I know actually I could draw a couple of triangles. We'll do it in a nice blue. Draw triangles like this, where the radius of the circle is 4, and this is a right angle. And this is actually going to be a 45, 45, 90 triangle, because the theorem we learned in geometry about the perpendicular radius in tangent theorem means that this is a 90-degree angle right here. So this is a 45-degree angle, and this is a 45-degree angle. And so then each side is just using special right triangles, 2 root 2 and 2 root 2. So it's just a division of radical 2. Take the hypotenuse 4 and divide it by radical 2. And that gives you the legs 2 rad 2. And so I think I kind of have an idea of what's going to happen here. I haven't found a slope yet, but I do know the equation of each of the tangents now, because a similar argument can be made for this tangent. And so if this is a radius of 4, then I know each of the sides would be 2 root 2 and 2 root 2. So I know that one of the tangents is actually going to be, we need to transform the point 1, 2. And so to get one of the tangents, I would need to go down and right. So I'm kind of looking at this distance. I need to use a better color. Let's use a nice black. I need to go down and right to get to the center of one of them. So to go down, I would need to subtract the vertical distance, which is 2 root 2. So subtract 2 root 2. And then the other distance is just going to be a horizontal distance of 2 root 2 as well. And in this case, I'm moving to the right, so I would need to add 2 root 2. And then the other coordinate point of the center is actually just going to be the same thing. So I need to take the point 1, 2 and transform it. In this case, I need to go, let's see, I need to go left and up. So I need to do minus 2 root 2 and plus 2 root 2. And this gives me the coordinates of the centers of the two circles. And so now all we have to do is find the equation. And yes, Dara, we can definitely do number 10. We'll do that after we finish this bonus question, okay? And so let's see. We have the coordinates right here, and I suppose all I need now is the slope. And all we got to do is find the derivative. So the derivative is equal to 2y dy dx is equal to derivative of 4x is just 4, right? So 4. And so if I divide, I get 2y, or excuse me, dy dx is equal to, it would be 4 divided by 2y, which is just equal to 2 over y. So the slope is equal to 2 over y. So if I actually find the slope of the tangent, so the slope of the tangent is equal to 2 over the y coordinate, which is 2, is 1. So the slope of the normal is the opposite reciprocal, which is -1. And again, why normal? Because we proved that it's going to lie on the normal because it has to be perpendicular to the tangent. That's where the centers are going to pass through. So the centers are actually going to lie on the normals, not the tangent. The center of the circle is very, very obvious. The center of the circle will not lie on the tangent. So I think we're done. All you have to do now is just write the equation of the circles. And so it looks like we need to write it down. So what is it going to be? It's going to be H comma K is the center. And I think we found the center of the circle. It's just that thing. And then it's equal to the radius squared, which is 16. And so why am I blanking on the formula for the circle? What do we have to do? We have to do like h minus k or something. It's x minus h squared plus y minus k squared is equal to r squared. Someone correct me if that's wrong, but I think that's it. So if I just plug my values in, so it's just going to be, I'm checking chat. Yes, that's correct. Thanks, CJ. So that is the equation of the circle. So it's just going to be x minus, and then I'll go and get my h value, which is the x coordinate of the center of the first circle. So I'm going to use this. So 1 plus 2 rad 2. And then we'll leave the parenthesis open, comma, and then we'll do y minus open parenthesis, and we'll grab this, 2 minus 2 root 2. And then that is equal to, oh wait, what are we doing? I need to square them. Oops, I was thinking of a coordinate again. So this squared plus this squared equals 16. So this is the equation of one of the circles. And the other circle is actually just going to be the other coordinate. So I'm going to use 1 minus 2 root 2 is my x, and 2 plus 2 root 2 is my y. So I'm going to do x minus 1 minus 2 root 2 squared plus y minus 2 plus 2 root 2 squared. Gotta close this, equals to 16. And here's the other equation of my circle. All right, so yeah, that's a little tougher problem. I'd say it's more like a bonus appropriate question, but not too bad, not too bad. All right, we're going to go to Dara. We've got Dara is number 10 requested, and we will go up to problem number 10, and we've got a nice problem here. Looks like probably the final problem of the night. It's 8:54, and I do have to leave, so we'll do this one, and then we'll call it a night. So let's try number 10. It says, let f and g be differentiable functions. Let f, g, and the derivatives of f prime, g prime, and x equals 1 and 2 be given. Okay, find the derivative of the following. Find h of x equals that. Find h prime of 1. All right, so let's find the derivative of h. So it looks like a simple quotient rule here. We'll do it. So low d high, so low times derivative of high is the chain rule. So it's derivative of f of g of x is f prime at g of x times g prime x. Okay, that's the definition right there. That's the definition of the chain rule. minus high d low, so f of g of x times d low is f prime x, all over f of x squared. Okay? And now I basically just need to go through and put a 1 everywhere and then solve the problem. So I'm just going to do this for a second. Watch this. I do that all the time in my worksheets. You guys have no idea that I've like deleted stuff, but just to get a little more room. So let's do h. Oh, wow. I forgot to reduce the font size. Oops. So h prime of 1 is equal to, still a little thick. We'll go down 1. So I need to do f of 1 times f prime of g of 1 times g prime of 1 minus f of g of 1 times f prime of 1 all over f of 1 quantity squared. So let's go ahead and solve this thing out. Looking at my table, f of 1 looks like it's 3 times f prime of g of 1, so g of 1 is 2, times g prime 1 is 4, minus f of g of 1 is 2 again, times f prime of 1 is 5, all divided by f of 1 squared, and f of 1 we said was 3, so this is just all divided by 3 squared. And the last thing I need is I need an f prime of 2 and an f of 2. So f prime of 2 is 6. I'm just going to put that right in here. And then I need an f of 2. F of 2 is 2. And I'm going to put that right here. So I'm going to get a final answer of, let's see, 3 times 6 is 18 times 4. Times 4 is 32. 4 is 72. Minus, delete that. 2 times 5 is 10. All over 3 squared is 9. So what is that? 62 over 9, which does not seem to be a clean number. I'm just going to leave it like that. So 62 ninths, sure. And then there was a problem that I deleted, so I'm going to go ahead and get that problem. So I'm just going to take this for a moment real quickly. And cut. Okay. And we will add a page below, and we will, oh, where's my page? Oh, is this my page? This is problem 2? Whatever, that's fine. We'll just put it right here. Paste. Okay, so we'll put that back. So that was A. Let's go find B, number 10. Here we go. So B asks for h of x equals 3 f of x g of x, find h prime of 1. So it's really just kind of like the same thing, just a different iteration. I'm not sure why I pasted that. I thought maybe I needed that work to move forward, but I don't need any of that work to move forward. So I'm just going to move on to B, which is just to find the derivative. Now, this is a big important fact. Don't let constants confuse you when you're finding derivatives. The derivative of h will just simply have a 3 inside of it. Now, don't even worry about it. Take the derivative as normal. The 3 is not going to affect anything. So fg of x is the product rule, right? It is not. It is not f prime x g prime x, which so many students want to say it is. It's not the derivative of that. You have to use the product rule, okay? So if we use the product rule, we'll do first times derivative second, which is g prime. And then we'll put the 3 actually outside of these parentheses here. So first times derivative second plus second times derivative of first, and all that evaluated at 1. So h prime of 1 is going to be 3 times f of 1 times g prime of 1 plus g of 1 times f prime of 1. Okay? And then I just have to use the table. So let's go find f of 1. F of 1 is 3. So this is 3 times g prime of 1. G prime of 1 is 2. So 2 plus g of 1. Oh, whoops, that was g of 1. Oops. G prime of 1 is actually 4. My bad. This is 4. This is 2. G of 1 is 2. And then I need f prime of 1, which is 5. F prime of 1 is 5. and then I just need to solve it. So this is 3 times 4 is 12, plus 5 times 2 is 10, which is equal to 3 times 22, which is 66, Okay, so I think that's it for number 10. I didn't erase anything else in the problem. So 66 is the answer to part B, and with that, it is exactly 9 o'clock, which means I'm going to cut the live review, and we'll do some more of these in class tomorrow. I hope that was helpful. I think we definitely did some of the more challenging ones. If I had to give you guys one to make sure you did before class tomorrow, it's certainly, without a doubt, problem number 4. I think 4 is a very interesting one. And also number 7, if you were not in the class period that we did number 7, I can't remember. I think it was my period D class we did 7, because Eli actually asked for it, which is a great pick. I would do that too, just to practice your chain and your quotient, and also your second derivative of using implicit. Okay, so you guys have yourselves a nice night, and we will see you in class tomorrow. I have an awesome review game planned. It's going to be so much fun. Maybe, perhaps. Have a good night. Oh, that's not it. That's the wrong thing, and that's the wrong tab. We're back. Ending stream. Have a good night.